because we can actually apply this to different situations now. Application problems like this: parasailer attached to a boat with a rope 72 feet long. Angle of elevation, now we're going to talk about that. From the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. So estimate the parasailer's height above the boat. Let's draw a picture. I just love my artistic ability. Draw a little bit down here. Okay, here's my boat. Now parasailer, I don't know if any of you have ever done it or not, but they hang this rope from the end of the boat, and there's some guy with a parachute on flying up behind it. So the boat's driving along and they go off on this in this parachute, and it pulls them behind the boat. It's actually pretty fun. All right, so that's the basic picture of it. Now, angle of elevation is if you take the starting point and you draw a flat horizontal line, then the angle from that horizontal line up to the line of sight, the thing that you're looking at, that's called an angle of elevation. And it tells us that that is 28 degrees. Okay. Next, it tells us that the rope is 72 feet long. Well, this right here is the rope. Now, how is that useful given what we were just talking about? Well, if you draw a perpendicular line down from that guy at the end of the rope to that horizontal line, we have formed a right triangle. Right, perpendicular means right triangle. Inside here is 28 degrees. This is 72. And then the last part is, what are they asking for? It says estimate the parasailer's height above the boat. That would be this guy, which is x. Okay, just like before, in order to solve, to find that other side given an angle, you have to identify what pieces you have. So we've got theta is 28 degrees. Looks like our hypotenuse is given. And what we're trying to find is opposite the angle. Okay, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA tells us that if I'm talking about opposite and hypotenuse, then I'm saying I'm talking about sine. Okay, sine of theta is opposite over hypotenuse. Plug in what we know. Sine of 28 degrees equals opposite x over hypotenuse 72. Now, are we finding the hypotenuse? No. Then that means that we're actually just going to multiply by the number, both sides. So x is 72 times the sine of 28 degrees, which is about 33.8. My feet. No, you love my pictures. Let's try the next one. Ben and Emma are out flying a kite. Emma can see that the kite string she's holding is making a 70-degree angle with the ground. The kite is directly above Ben, who is standing 50 feet away. To the nearest foot, how many feet of string has Emma let out? Now this is going to require a lot more artistic ability. Let's see, there's Emma, right? She's holding on to this string out here, and there's the kite. What do they have, the little strings on it? Whatever, close enough, right? Oh, there we go. There's Emma and her kite. And then the kite is directly above Ben. So Ben must be far away, so he must look a little smaller. Ben, Emma. All right. Ben is flying a kite. Emma can see the kite string she's holding is making a 70-degree angle with the ground. So right here, now this isn't the ground, but it's parallel to the ground. So we're going to consider it to be the same thing. Okay, 70 degrees right there. And notice I drew the line out to Ben because it tells me that the kite is directly above Ben, which means I can now draw a perpendicular line from the kite down to Ben's big old head for his little tiny stick body, and that forms my right angle. Okay, he is standing 50 feet away. 50 feet away corresponds to this guy right there. Then it wants to know how many feet of string has Emma let out. That's going to be this last piece up here. And that's our unknown. All right, we now have our right triangle. Emma's over here. We've got 50 down below, 70 here, and we're trying to find x. All right, let's label. Let's see, theta is 70. I'm given an adjacent of 50, and we have to find the hypotenuse. Okay, adjacent hypotenuse. In my head, I'm saying SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay, looks like it's going to be cosine. Cosine of theta is adjacent over hypotenuse. Cosine of 70 equals 50 over x. Now, we're finding the hypotenuse, which means you're going to be taking the number and dividing it by the trig function. But again, I'm going to show you why, so that those of you that want to have the understanding can see it. Multiplying both sides by x, it gets rid of it in that denominator. So now it looks like this. X times the cosine of 70 degrees equals 50. Feels weird, but our next step is to divide by that trig function. Whatever you do to one side, you have to do to the other because it cancels it over there on the left side. Okay, x equals 50 divided by the cosine of 70, which is about 17 feet. About 17.1. We'll call it 17. That's close enough. Okay, that is the answer to this one. Again, if you want to remember the shortcut, if you're finding the hypotenuse, when it's the hypotenuse, your answer equals the number divided by the trig function. See how we ended up down here in the end? 50, the number given, divided by cosine of the angle. And that would have saved you a little bit of steps, but just in case you're not okay with remembering the shortcuts, if you'd rather understand the pieces, which I encourage, there you go, that's how it happens. One more example. It says a student looks out of a second-story school window and sees the top of the school flagpole at an angle of elevation. Sorry, skip that word right over it. Angle of elevation of 22 degrees. The student is 18 feet above the ground and 50 feet from the flagpole. Find the height of the flagpole. Woohoo, I get to draw pictures. I'm so excited. All right, there we go. There's my picture. I know it took me a minute, but Had to put a lot of detail in there to make it, you know, look perfect. I mean, I'm impressed with my picture. I hope you are too. Okay, so we've got this kid in a second story window. Here he is. Let me draw him in darker color. Here's that student pushing the button. Right? Hands hang out the window because he's a delinquent. Maybe it's a she. I don't know. We're going to put some more hair on him. Who? Them. We'll give them more hair. Okay, it says that the student looks out of the second story window and sees the top of the school flagpole at an angle of elevation of 22 degrees. So again, remember that we've got this sight line and they're looking up at the top of the flagpole. And this is that angle of elevation from the line of sight up to whatever they're looking at. So this angle right here is 22 degrees. Okay, the student is 18 feet above the ground. That means that this distance from the student down to the ground is 18 feet. I'm looking at that and going, wait, that's not even in the triangle. What does that matter? I don't know. We'll just label it and come back to it later. Okay, and then it also tells us that the student is 50 feet from the flagpole. So this distance from right here to here, or even right here to here, because it's the school, is going to be 50 feet. And we want to find the height of the flagpole. So we're trying to find this guy over here. Okay, now we've got a picture all diagrammed up. Cute little school that I drew by hand myself. Flag that I put the colors in myself. Here's the picture that we actually have right now as far as a triangle is concerned. This is our right angle. This we decided was 22. This is 50. And then this distance right here is 18. And here's kind of the ground of everything. Well, since we are trying to find this whole thing, if this guy from here to here is 18, that means this guy is also 18 feet. So what we really need to find is what is this guy? Because whatever that value is, if I add 18 to it, I'll get the whole thing x. So let's call that guy A. So here's what I'm solving. I've got 22 here, 50 here, and I don't know there. So angle, I've got opposite and adjacent. So of course I'm going to use tangent of the angle equals, I don't know, over 50. So my I don't know side is actually going to be 50 times the tangent of 22 degrees, which is about, so I get about 20.2 feet. Okay, so that's this little part. So the final answer, your x value, your flagpole, is the 18 feet from the ground up to the student plus the 20.2 feet that was the rest of the distance up to the flagpole. So altogether it is 38.2 feet.